Welcome back for this video session, and in this video we are going to be trying to solve one more problem which is related to the spring and mass system, right? And in this case I am going to read out the problem here. An unknown mass m is attached to one end of a spring stiffness, the spring of a stiffness k. He has taken the one end of a mass is connected one end of a spring is connected the mass, and he has a spring constant is going to be k, and having a natural frequency of 6 Hz, right? When 1 kg mass is attached with the m, the natural frequency of the system lowered by 20%, right? That means here one system, that is going to be the spring and mass they attached, right? And 6 Hz of the natural frequency was generated. After certain time, what he did it, and he was added 1 kg of mass to the initial mass of the system, right? And the natural frequency of the system is lowered by 20%. If you assume that this is the 100%, then it is going to be 20% less of that. 100 minus 20, the 80% it has recorded after the addition of the 1 kg of mass to that was number to determine the value of the unknown mass m and the stiffness k. So the totally from this one we need to calculate the mass of the system k1 and mass of the system m, and the stiffness is going to be the k we need to calculate. So in this case, this problem I have converted into the given data, right? What is the given data? From this the problem I was identified unknown mass I had given m. M is going to be the mass of the unknown system, and spring stiffness is going to be the k. This is the two parameters we have identified from the given problem. And the next one, the natural frequency of the system 6 Hz is given, that is going to be the, I am considering that as the f1, right? And after certain time 1 kg of mass added to the initial mass m. So the total mass that is equal to m plus 1. Right? And the total, that means the natural frequency after the addition of the 1 kg to the initial mass, that is equal to the f2 is equal to f1 into 100 minus 20 by 100. So then the f1 into 80 by 100, this is the frequency we are going to be getting. So then what you want to calculate here, the calculation part is going to be very clear that the mass of the system and the stiffness of the system we need to be calculated, right? And this is going to be the solution. How we are going to be solution? We are going to give the solution as we know the natural frequency f1 is equal to, what's the formula we do have? f1 is equal to 1 by 2 pi square root of k by m, we got it. Similarly, the second mass, that means 1 kg of mass we added after certain time, that I am going to be taking the f2 is equal to 1 by 2 pi square root of k by m plus 1. Right? And we got this one. So once we got it to the f1, and here is going to be the f2. So then these unknown parameters, we know f1 is going to be the 6 Hz we do have, right? And the f2 is equal to, that is available in terms of f1 by f1 into 80 by 100. So then I am going to be taking the equation 1 and equation 2. So then what I am going to be taking here, 1 by 2 I am going to be dividing. So, and this is going to be the f1 by f2, that is equal to, what is this one? 1 by 2 pi square root of k by m divided by 1 by 2 pi square root of k by m plus 1. In this case 1 by 2 pi is going to be cancelled, and f1 is going to be the 6 Hz, and then f2 is equal to f1 by 80 by 100, that's we are going to be substituting here. And finally we are going to be calculating the k and m values. So once we are taking the division of 1 by 2, the two equations f1 by f2, now I am going to be substituting the value of the f1 and f2 in this equation. I am going to be cancelling 1 by 2 pi, 1 by 2 pi, but the simplification I am writing here, the f1 by f2 is equal to square root of k by m divided by k by m plus 1. Right? And further simplification, what's the f1? f1 is equal to, already we do have 6 Hz, the 6 by, what is the f1? f2 is equal to, already we written that F1 into 80 by 100, that's I am going to be writing 6 into 80 by 100%. That means that is equal to square root of k by m, square root of k by m plus 1 I am going to be at 80. So then from this equation, further simplification, that's going to be 6 by 4 by 8, right? That is 4 by 8, that is equal to 1.25 whole square, that is equal to k by m divided by k by m plus 1. So from this equation, the k is going to be cancelled. From that I am going to be writing here, that is going to be further simplification from this equation, 1.25 whole square, that is equal to m plus 1 by n. This is the equation we got. So further simplification from this one, what we are going to get in here, so that's going to be 1.25 into whole square, and I am going to be multiplying that equation 1.5625 m, right? That minus m is equal to 1, right? So this is here we are going to be, m is going to be the common from this equation, that's I am going to be removing. So m is equal to 1 divided by 0.5625, that's finally that is equal to 1.778 kgs. This is the way we can calculate the mass m. Once you calculate the mass value m, then we can substitute in this equation F1 so that we can calculate the value of the k value. Right? That's F1 is equal to 1 by 2 pi square root of k by m we do have. F1, what is the value? 6 edges already it is available. That's I am going to be substituting 6 into 2 pi value, that's I am taking to this one, that is going to be whole square, that is equal to k by m. As we know that m is equal to 1.778 kgs, thus I am going to be multiplying. Finally, the k is equal to, what is the value we are going to be getting here? That k is equal to, from this equation, 25,500 26.9 Newton per meter cube. Right? And this is the unknown mass is equal to 1.778 kgs. Right? And next one, the K, the stiffness of the spring is equal to 2526.9 Newton per meter. Right? So once again, we can see here the summary of this problem. The unknown mass m. Then what happened? There, that is connected to the spring. So that is the K value, and it maintains the 6 edges. When the mass 1 kg is attached, after certain time 1 kg of the mass is attached to the system, and the natural frequency was required 20% less than the original one. Then finally we need to calculate the mass and the K value. That's going to be mass is equal to 1.7 kg, and stiffness of the system is going to be 2526.9 Newton per meter square. I hope you understand how to do this problem. Thank you.